Hello, in this video we're going to introduce logarithmic and exponential equations. So logarithmic and exponential equations are two very special looking functions. They're very different from our polynomials in that they take these very steep curves. In the case of the exponential, in blue, it's some number, like 3, to a power. And this is what makes it very different than our polynomials, which is some variable to some static power, like 2. And so, as you can expect, even small increases to our exponent can make our number skyrocket. Now, the logarithmic function is what we call the inverse. It's kind of a flip. If we're thinking about exponential functions, and we can see here our domain is going to be from negative infinity to infinity. We can put in anything that we want for x. And we can see that our range is from 0 to infinity. The logarithmic function is built to be the opposite. In this case, we built it to have a domain from 0 to infinity and a range from negative infinity to infinity. So again, these are opposite equations. Now, these general forms should look very familiar. They should look just like, let's see, we had vertex form for parabolas. We had if we write it like this, it doesn't really look like it, but really this is slope-intercept form, or slope-point form in disguise. This is what all of our functions look like. So in the case of vertex form, our h and our k was our vertex. In the case for exponentials, our hk is going to be this number here, and we can see that based on the following. Let's say we have this basic function, 3 to the x. If I plug in 0, my y value will be 1. And it doesn't matter whether this was 3 to the x, or 4 to the x, or 5 to the x, or 7 to the x. If I plug in 0, some number to the 0 power will be 1. So, like a vertex for parabola normally starts at 0, 0, this is going to be our starting place for exponentials. And so when we add in this shifting of h and k, we can think about our starting point as h, k plus 1. Now, since logarithmic functions are supposed to be the opposites, the idea is if we plug in 1 into our basic logarithmic, then our output should be 0, because it's the opposite of an exponential. Which means that our start, when we're trying to draw a logarithmic function, would be h plus 1 and k. So they're a little bit weirder. If we're talking about shifts with the exponential and logarithmics, they're off-center by this little bit. But it makes sense. If I'm plugging in my zeros, I can see this will always be 1. And as we'll see later when we get into logs more, log of 1 is 0. So the last thing to talk about is how we get between these two forms. So the relationship here, if I have b as some number, I can actually rewrite this as x equals log base b of y. And vice versa. If I have some log, then I can rewrite it as an exponential function. So, based on this form, we may be able to see why we even care about logarithmic functions. And it's because if I have something like 3 equals 2 to the x, up until this point in the course, we have no way to figure out what x is. But if we turn it into its log form, we can see we actually can solve for x now. X is equal to log base 2 of 3. And in later videos, we'll learn how to put that in our calculator. Yeah, that's everything we need to know about exponential and logarithmic equations.